Hello everyone. So for this part of this video I will work on class example 24, which is about the Snyder's method, and for class example 25 I will work on the NRCS method. So both of these are for developing for the synthetic hydrograph. Basically when you don't have the enough flow data or something like that from the channel geometry or from some well established chart, we can still develop the synthetic hydrograph. Okay, so for class example 24 it's about the Snyder method, and it said that for a basin of 500 kilometers having L equals to 25 and LC equals to 10 kilometer, derive and plot the 4-hour unit hydrograph. Assume CT equals to 1.6 and CP equals to 0.16. Okay, so for this one what we will do, we will try to identify what are the given values and what are the things we need to find out. Okay, so I thought since it's too a good number of equations we need to use here, so I copied everything from your class lecture here, and I will just write down what values are given and what we need to find out. Okay, so the very first thing is find out L and LC. So L is given, which is 25 kilometer, and LC is 10 kilometer, and the area of this watershed is 500 kilometer square. Okay, and then we have the CT and CP. So CT is 0.16, sorry, this one is 1.6 and CP is 0.16. Okay, so that's what we know. We also know duration of rainfall excess other than standard duration adopted in the study. So for our case TR is actually 4 hours. If you notice here they said that plot the 4 hours unit hydrograph. Now the question is, what is TD and TR? TR is the duration of rainfall excess other than standard duration adopted in the study, and TD is the standard duration of the rainfall excess in hours. That means based on the channel geometry, what should be the duration of rainfall excess, that is the TD. So that's what we will calculate. If you look at here, TD, TP over 5.5. Now the TP, it's actually from the center point of here, center point of the standard deviation to, not standard deviation, like standard duration of rainfall excess to the peak, TP. So it's based on channel geometry. So we need to calculate the TP first, and then once we have the TP we can calculate the TD. Okay, so that is our very first step. That step 1, calculate TD. So for TD it's TP over 5.5 and TP is CT LLC 0.03 5.5. And so what we will do, we know the CT is 1.6, we know the L is 1025 to the power 0.3 5.5, and if we do the calculation properly it will be 8.38 over 5.5 equals to 1.52 hour. Okay, so that is clearly different than 4 hours, right, which is TD. Okay, great. So that is our step 2. Now step 1. Now for step 2, since the duration is different from the standard duration, so if you notice we actually need to find out what will be the QPR now. Okay, peak flow for the duration TR. So that will be our next step, like how can we find out the QPR. Okay, so step 2 will be find out the QPR. Now if you look at the equation, QP, that is the step to calculate the QPR. So it's QP TP over QTPR. Now what is QP? Peak flow for standard duration TD. This is the QP. Okay, so we have multiple steps here. We need to calculate QP, we need to calculate TPR, and we already know the TP, which is 8.38. okay, so I will just write down 8.38 because that's what we got from here. Okay, so let's start calculating this one. What is QP, what is TPR, and we already know the TP. Okay, so for QP it's CPA over TP. So CPA is 0.16 500 and the TP is 8.38. So this is 9.546 if we do the calculation. Okay, feet cube. Okay, now we know this one, which is QP is 9.546. okay, and TP is 8.38, and now we need to know what is TPR. Okay, so TPR is TP plus 0.2 TR TD. So we already know what is the TP, which is 8.38.25, and TR minus TD. So TR is 4 and TD is 1.52. so if you do the calculation, it will be kind of 9 hour. Okay, so 9, and once we have all of this, it is 8.89. Okay, I think my previous one, this one will be meter cube per second, as the area is in kilometer square. Okay, so this one will be meter cube per second. Okay, so our step 2, finding QPR, that part is done. Okay, so my next step is calculate, like my plan is we need to actually find out what are the coordinates of this hydrograph, right? So what I will do, I will draw a table at the very end just to list all the coordinates. Okay, so this one will be Q, this one will be time, 1 2 3 4 5. Okay, so this one is the very first one is 0 0, obviously. Okay, and the midpoint will be Q peak, and then the time, and this one is the Q at the end, and the time. Okay, that's what we will do. So what we will do now, we will find out the next step. Okay, so it will be okay, so we'll do that. So our next step, we already know 0 0, we know this one Q peak. Now the next step, we will try to find out what is the very final, this one. Okay, so this is our 0 0, we already know that. This is our Q peak and like QPR with the PR, we don't know the PR yet, and this one will be the very last one, which is 0 with the time base, right? Okay, so we need to find out at what time the QR will be achieved. So that is the PR. Okay, so let's write it down. So how can we find out PR? That's the next step here. Okay, so let's calculate PR. Do we have any equation for PR? Okay, let's check. How can we find out the PR? So our PR is basically the at which time we will have the peak flow. So let's find out the PR, which is, I'm not seeing the equation here. Okay, so what we will do, we'll say our step 3, find the PR at which time QPR will be achieved. Okay, so how can we calculate that? PR equals to TR over 2 plus TPR. Okay, so TR is what is TR, which is 4 over 2, and QTPR is, we already got, which is the 9 hour. So in total that is actually the 11 hour. Okay, so let's find out that class, if you look at the equation for the PR, you can see only this portion is like this portion is that TPR, and up to this portion, that is actually TR over 2. That's why the PR is TR over 2 plus TPR. Okay, so what we will do, I will go to the Q peak. We already know our Q peak, which is the QPR, which is 8.89. we also know the time now, which is 11 hours. Okay, now our next step is, if I go to here, so we know this one, and then we need to find out the very last one, when all the rainfall will be gone. Okay, so we need to find out the time base T. So how can we find out the time base T? So let's find out that time base of the unit hydrograph, which is 3 plus, let's see here, 3 plus TP over 8. Okay, so let's find out that is our step 3, find T. Okay, so what was the TP? We got 8.38 over 8. So if we do the calculation, and if you look at the unit time base of the unit hydrographs in days, but we are plotting in hour, so what we will do, we'll find out in days, which is 4.05 days. If we calculate that, it will be 97 hours. Okay, and if you look at here, at that time the discharge is 0, so we got our last point, which is 0.97 hours. Okay, we got 3 points, but within these 3 points we can't work, we can't actually develop the, like we can, that will be just kind of triangle, but we can't get all the other values here. So then we need to find out W50, W75, which is a point where the Q is 0.75 QPR, and we need to find a point where Q50, which is 0.5 QPR. So how can we find that? like basically we are trying to find this width. Okay, so how can we find that? So what we will do, we will use these two equations. Since we are using the metric unit, we will use this one and this one. Okay, so let's work on that and see if we can find that. So that will be our step 4, W50 and W75. Okay, so find out the W50, 0.23 multiplied with 500, 1.08, and QPR is 8.89 to the power 1.08. Okay, so this one is if we do the calculation, 70.86, 18. Now we are trying to find this width, which is actually the time, so it will be 18 hours. And for 875, if we do 0.13, A is 500, 1. Here 1.08, and Q equals to 1.8.89, 1.08. Okay, so if we do that, I got 10.093. Basically we can actually get that 10 hours. Okay, now once we get this one, which is here 0.75, we got 18 hours, we got 10 hours. Now if you notice the very first one, it will be, as a rule of thumb, the width W50 and W75 are proportioned each side of the unit hydrograph prick in the ratio 1:2, with the short side on the left on the synthetic unit hydrograph. Okay, so that means this part will get 1/3 of 18, this part will get 1/3 of 10, which is 6, which is 3.33, and this part will get this part will get 2/3 of 18, which is 12, and this part will get 2/3 of 10, which is 6.667. Okay, so if you look at that, this one is 12, this one is 6, and if I remember the peak, it was actually the 11. That means 11 minus 6 will be your this point, which is 11 minus 6, and this point will be 11 plus 12, right? And this point will be 11 minus 3.33, and this point will be 11 plus 6.66. Okay, so those will be the last few points here. So if I say 11 minus 6, which is 5, and this one will be 75% of QPR. Okay, and this one will be 11 minus 33, which is something 50% of QPR. Okay, and the next one will be 11.667, 50% of QPR, and 11 plus 12, 70% of QPR. Now you may wonder why I wrote in that sequence, because if you draw this one. Okay, that is your peak, and that is the 75%, that is the 55%. So if you notice now, like 0, then 50% and 70% and the peak. Okay, and then you will get again 70% and the 50%. Actually I did that in reverse way. Okay, so that 50 will be here and 75 will be here. The same thing, 50 the 75% will be here and 50% will be here. Okay, so once we have all of these coordinates, what we will do, we will go to the Excel copy, Snyder method, and what I did, this is the 0 and this is the 0 0, if you look at that, and this is the 97, very last one, and all of these are like 11 minus 6 and 11 minus 3.33, something like that. All of these are here, and once you plot that, you can actually get this type of shape with these 7 points. So what you will do for your copy, once you have all the numbers and everything, you will just plot on your copy here on Excel curve. Okay, so that will be the class example 24. Okay, now let's work on class example 25 here. So it says that for a basin of 5,000 kilometers square having L equals to 25, LC equals to 10, derive the 4-hour unit graph using NRCS method. Okay, so this time it's the same question, but we are using the NRCS method. So what we will do, we will try to calculate this one. So for this one, what you need to do, if you notice, there was a table here 9 11, which is attached to your copy as well. So this is the ratio T over TP. Okay, and this is the Q over QP. So for finding T and Q, what we need to do, we need to find out T, which is T over PR multiplied with PR, and Q equals to Q over QP multiplied with QP. So basically we need to find out PR and the QPR, right? Now here all the equations, PR is exactly what you got from the Snyder's method, so the equation is same. So I will just write down what the PR we got, 11 hours. Okay, but for the QP or QPR, the equation is a little bit different. Since we are using the metric unit, I will use this one. So let's find out what is the QPR. 28 multiplied with what is the area here, it's the 500, and the PR is what is that? Oh, I'm sorry, the PR will, like, we need to find out the PR, so let's find out that. So the PR is TP over TR over 2. So this time I think the only change for Snyder's method, we used the TPR here, not TP. So here it's a little bit different. So what we will do, TR is 4 over 2, and the TP, it was actually 8.38. TP was actually like based on based on the channel geometry, what will be the TP, That's the what will be the time to reach the peak? That's the TP. So here we used 8.38. Okay, so that's the thing. We already know that from Snyder's method, and now it's 10.38 hour. So if you want, you can round that into 10.5, or you can keep that as it is. So once you use that value for the QP 10.38, you will get kind of like almost same as 9.90 meter cube per second. Okay, so what we will do now, here in column, with each number we will calculate the PR, and then we will go to the table here and find out for 0, 0.2, 0.5, 0.8 what is the Q over QP. Suppose for 0, Q over QP is 0. For 0.2, QP over QP, Q over QP is 0.1. Okay, so what we will do, 0 multiplied with PR, which is 10.38, which is 0. Here 0 multiplied with 9.9, again it's 0. So that's what we will do. So what I will do this calculation on Excel, and I will go to this Excel here, NRCS method. So if you look at that, for each one I already got the value from that table. What is the table? Table 9.1. okay, and now what we will do, I will just do the calculation here, and if I check the color, it's actually, what is the number here? This one is 10.5 multiplied with 13, so 10.5. I used that instead of 10.3 what I just rounded that, but you can actually keep 10.3 and calculate all the T and Q, and once you have that, you can actually plot that. So that will be the hydrograph you got. Okay, so that's the NRCS method. So Snyder's method and NRCS method, both of these are without any actual channel data, without actual any flow data, but based on the like the Snyder method, it was based on the channel geometry. If you look at all the values, it is based on length and everything, and the NRCS method, it was based on all the developed table. The NRCS, they actually develop from a countless number of basins in different region. From that table we actually developed that. Okay, so that's it. Thank you very much.